Sri Sai Ram. Welcome back to the 7th session of this lesson, Force and Laws of Motion. In the previous lesson, we have solved some of your textbook questions. In this session also, we will proceed with that. So let us play again. I hope you are ready with your pen and book and let us solve along. What is the problem given? This is the 11th problem in your exercise. Two objects, each of mass 1.5 kg, are moving in a same straight line, but in opposite directions. Right? Let us mark. What are given? Two objects, each of mass of 1.5 kg, and they are moving in same straight line. All right? But in opposite directions. So these are the clues we have from the problem. The velocity of each object is 2.5 meter per second before the collision. So before the collision, the velocity of the masses are also given. Each is having the same velocity, that is 2.5 meter per second. That is before the collision. On collision, they stick together. After collision, they don't fall apart. They don't go apart. They stick together. So what will be the velocity of the combined object after the collision? So as they are not going apart, they are sticking each other. Both together form a new object, right? So he is asking what will be the velocity of the combined object after the collision. If you see and visualize this question, in the law of conservation of momentum, we have hinted you one sort of problem where we can easily solve it. So what is that? A symmetry. This problem hits on the point symmetry, right? Now take the two objects, one object, two objects of each of 1.5 kg. This is also having 1.5 kgs, right? Now they are moving in the straight line, right? So let us draw a straight line connecting them, and both are moving in the opposite directions. So this object is going in the right direction and this object is going in the left direction. They are going towards each other in the opposite directions. All right. They can also go apart, right? But after colliding, in order to collide, they should go what? Face to face. Now he's telling that after collision they are sticking. So after collision they are sticking to each other. So you can see a symmetric situation here. If you draw a plane of symmetry, what is a plane of symmetry? It is a vertical plane which divides an object into two halves. So this becomes a mirror image of this object, right? If you put a mirror here and see this object, you can easily able to tell, you cannot able to differentiate between this object and this object, right? Because it is having the same mass and it is moving with the same velocity and both are approaching each other. So this is identical to this object. The situation is very much identical. So what we have discussed in the law of conservation of momentum, when you have a symmetric situation before collision, it should able to follow the symmetry after the collision. So how can it follow a symmetry after the collision? There are two ways, right? One way is after colliding, after collision, these bodies with same velocity may move apart. That is also symmetric situation, right? Two bodies are going apart. As they are coming here in the same direction, they will move apart in the opposite directions. That is also symmetric situation. What is another symmetric situation? That they collide and stick. When they collide and stick, what happens? In order to maintain a symmetry, what it has to do? Should it move? Should the combined object move? They are sticking each other means both are combining and forming a one object. They are behaving as a one object. Right? So after collision, in order to maintain the symmetry, should it move? No, it should not move, right? If it moves, it breaks the symmetry. So in order to maintain symmetry, if they are sticking each other, they should not move. So our intuition says that it should not have any velocity. Before collision, they are moving with how much velocity? 2.5 meter per second. It also coming 2.5 meter per second. So if this direction we take as positive, this will be your negative. So velocity is a vector quantity. So after sticking each other, our claim using the symmetry thing, we are saying that it should not move. Right? So the final velocity of this system is 0. Our conclusion. Now let us go stepwise without using the symmetry and cross verify whether what we have discussed is right or wrong. So let us write what is given in the problem. What is given? The mass of the object m1 and m2 are 1.5 kg each, right? Initial velocity of this object u1. If the object which is coming from the left is u1, object which is coming from the right is u2. If we take this as 2.5, this will be minus 2.5 meter per second and meter per second. Right? The initial velocity of the first object, this is u1, is 2.5 meter per second, and initial velocity of the second object, which is moving in the opposite direction. It is traveling with the opposite to with respect to u1, right? So its velocity is minus 2.5 meter per second. Now let us proceed. When the two masses stick together, mass of resulting object is what? When the masses are sticking together, you have two masses, they are sticking together, 1.5, 1.5. So this whole forming one body, what happens? What is the mass of this system? m1 plus m2. You need to add the two things, right? So it becomes 3 kg now. So before collision, they are individual. After collision, they stick together, they become 3 kg. As per the law of conservation of momentum. So as per the law of conservation of momentum, what we discussed, the momentum of the system should not change. If these two bodies become one system, so before collision and after collision, the total momentum of the system should not change. Right? That is the law. Now before collision, we know each object's velocity. After collision, the combined object velocity we want to know. But one thing we know, that the momentum must be conserved. It should not change for the system. So the total momentum before the collision of the system is equal to the total momentum after the collision, right? So let us find out the total momentum before the collision. Total momentum before the collision gives rise to the sum of the individual momentum of one body plus momentum of another body. So one body is traveling with 2.5 meter per second, and another body which is traveling opposite to the body 1 is having the velocity minus 2.5, because momentum is a vector quantity. We need to make note of these signs. You can see these two will cancel out, right? 1.5 into 2.5 plus 1.5 into minus 2.5. These two will cancel out, because here you have minus, here you have plus, same magnitude, same value, it will cancel out. Both will cancel out, it will become 0. So what does it say? The initial momentum of the system is 0. Now what should be the final momentum of the system? Should also be 0. And they are sticking together. You know the mass. So m1 plus m2, this is the whole mass after the collision. Therefore, the total momentum after the collision, what is the total momentum of after the collision of the system? They are sticking each other, two mass, combine the mass 3 kg into the velocity of that mass is equal to what? Initial momentum, 0. So what happens? 3 into V is equal to 0. Therefore, V becomes what? 0, right? That is what here given. So the final velocity of the combined mass is 0. That is what we predicted using symmetry, right? So using law of conservation of momentum, we got this. So it easily verifies our symmetry problem. So this implies that the object formed after the collision, which implies that the object formed after the collision has a velocity of 0 meter per second. That means it is not moving. Its velocity is 0 means what? It is not moving. The combined mass which is sticking with each other, the two birds sticking with each other, after sticking, they are not moving. So it verifies the symmetry and it also verifies the law of conservation of momentum, right? So I guess everybody followed this and you have already worked it out before me. So now let's go to our next problem, all right? What is the problem? According to the third law of motion, when we push on the object pushes back on us with an equal and opposite force. If the object is a massive truck parked along the roadside, it will probably not move. A student justifies this by answering that two opposite and equal forces cancel each other. See, a student justifies answering that two opposite and equal forces cancel each other. Comment on this logic and explain why the truck does not move. So here you have a situation, you have a truck. So you are pushing it. Will the truck move? No, the truck does not move. So you can argue that you are applying an action on the truck. In turn, the truck is applying reaction force on you. So the forces cancel each other and the truck is not able to move. You are not able to move the truck. Wait. Then if you use this argument, then you should not able to move anything, right? If you want to move a small thing like chair, it moves. But using this argument, what happens? You push a chair, it should also exert an equal and opposite force on you. Then you should not able to move the chair also, right? With using this argument. This question hits a common misconception that we tend to think that action and reaction forces cancel each other. Right? Let us go and explore it. Now, this is a truck. Okay, you are here. You are pushing the truck. So we are, this question what we said, it is hitting the common misconception where we tend to think action and reaction forces are cancelling each other. When the forces will cancel out each other, when it is under the influence of a balanced force. So what is the condition for the balanced force to be there? It should act on the same object, right? If this is one object, one force is acting in this direction and the same amount of force means same magnitude of force if it is acting in the opposite direction, then this net force on this object will be 0. Then we can say this force is cancelling out by this force because it is acting on the same. same object. Now, for example, you are pushing the truck in this direction with the force, with some force. For example, the same thing. This is a truck. Here are you. Okay. So you're pushing the truck in this direction, and in turn this truck is pushing you with the same magnitude of force. So now the force is on two different objects. It is not on the same object. So how can you tell that these two forces are cancelling each other out? Right? Now you can say, okay, this is not balanced force, this is unbalanced force. If this is unbalanced force, you should able to move this truck, right? So who is playing the spoil spot here? It is under the unbalanced force. Then why should, in this frame, then why shouldn't you move here, this truck? Who is playing a spoil spot? If you are on the ground, this friction here is playing the spoil spot. So as the truck is a massive object, it has a huge mass, so static friction for this truck will be more by the ground. So the ground is applying opposite force of friction on this object, which is halting this truck to move. You are pushing it, but the friction is halting this truck. Right? So is the friction is not applied on you? Yes, friction is also applied on you. You are pushing the ground in the backward direction. Friction is acting in the forward direction just to keep you from moving. Alright. So when will the object will move? When you apply large enough force where you overcome this friction. That means you have the force which you are applying on this object in this direction, friction is in the opposite direction. If you overcome the force of this opposing force, this friction which is stopping the truck, then only this truck will start moving. Understood? So this force is not balanced by the opposite reaction force, but this force is balanced by the frictional force which is offered by the ground. Did you understand? So that now you can say the friction force is, now you want to learn that frictional force is a self-adjusting force. For example, there is a limit for the friction. For example, say there is a 5 Newton limit for the friction, and it is a self-adjusting force. If you apply 1 Newton on this truck, it applies, the friction will apply opposite 1 Newton. If you apply 2 Newton, it will apply 2 Newton. If you apply 3, it will apply 3. If you apply 4, it will apply 4. Once you break the barrier of this frictional force, the maximum limit of this frictional force, which is 5 Newton, it breaks down and the object starts moving. So what we want to say is this force which you are applying is balanced by the frictional force which is offered by the ground, not by the reaction force which is offered by the truck. Understood? So if the friction is not there, absolutely there is no friction, then if you just touch it, the truck may move. In this case, there is a friction. Because of this friction, it is not able to move. That is our answer. Let us see how we have written the answer. Since the truck has a very high mass, the friction between the road and the truck is high. When pushing the truck with a small force, the frictional force cancels out the applied force and the truck does not move, right? The frictional force that is cancelling out the applied force which you apply on the truck. Alright, so when you when you just try to push over the friction, when you surpass the frictional force, then only it can move. So it is not the reaction force from the truck that is stopping it. It is the friction that is stopping it. This implies that two forces are equal in magnitude but opposite direction, right? So the friction is equal in magnitude but also opposite in direction as far as you are within the limit of friction. In this case, because it is not moving, that means what? The friction is acting in the opposite direction and you are applying the force in the opposite direction. So these two are cancelling each other out. Hence the student's logic is correct. If the student tells that action and reaction forces are cancelling each other, then his logic is wrong. Here he just mentioned that two forces are equal in magnitude. What are the two forces here? The force with which he applied and the frictional force which is offered by the ground. So the equal in magnitude but opposite in direction. That's why you can deduce, you can say that student's logic is right. Has he told that action and reaction pairs are cancelling each other out, then he is completely wrong. It is not the action and reaction pair that are cancelling each other. Because the truck is static, you can say it is under the balanced force. The balanced force is the forces acting on us, acting on the truck are by you and by the ground. Alright, this answers your second question. Now let's go and see the third question. A hockey ball of mass 200 grams traveling at 10 meters per second is struck by a hockey stick so as to return it along its original path with a velocity at 5 meters per second. So the hockey ball of mass of the hockey ball he gave you, it is traveling at 10 meters per second. So initial velocity is also given to you and it is being struck by a hockey stick. The hockey ball is moving, the hockey stick, it is being struck by it. So as to return it along its original path with the velocity of 5 meters per second. Along its original path. So this is also important because if it is coming in this direction and the hockey stick is hitting and it goes back in the same original path. So this is a great hint. Calculate the change in momentum occurred in the motion of the hockey ball by the force applied by the hockey stick. So I guess you are ready to solve it. So pause here and try to solve and then come back and watch this video. Hope you have solved it. Now let's check. The hockey ball of mass 200 grams. Now let us visually picturize it. So you have a ball. It is going in this direction. Okay. And it is hit by a hockey stick. It is hit by a hockey stick. It comes and it goes back in the same original path. So it is given that it is having a mass of 200 grams. That means 0.2 kg. 200 grams. Okay, you imagine there is no space to write there. Then, so it is coming back with in the same original path. So as it is moving, it is having a velocity of 10 meters per second. When it is being hit by the hockey stick, it is coming back in its original path with the magnitude of 5 meters per second. Coming back means what? It is changing its direction. When it is changing its direction, so he gave the magnitude of 5 meters per second. Is it right what I wrote? This problem is hitting at the misconception on the vector direction. So many of you may just write 5 meters per second here because it is given. But he has told you that it is returning along its original path. That means it is also changing its direction. That means its velocity is minus 5 meters per second. Alright. So Now it's very easy. You know the mass of the ball, you know the final initial velocity and the final velocity. Just we can easily able to calculate initial momentum minus final momentum or final momentum minus initial momentum. Either of the two will give you the magnitude of the change in momentum. Just go and calculate that. So this is the main point which you want to emphasize on. So once you have all the values, you can easily calculate the change in momentum. Let's go. What is given? Mass of the ball 200 grams, which is equal to 0.2 kg. Initial velocity of the ball is 10 meter per second. Final velocity of the ball v is minus 5 meter per second. So this is very important. Initial momentum of the ball is what? Mass times initial velocity, right? 0.2 kg into 10 meter per second gives you 2 kg meter per second. So this is the unit of momentum. Final momentum of the ball, the same thing. Here the velocity is minus 5. So it becomes minus 1 kg meter per second. Therefore the change in momentum, mv, final momentum minus initial momentum. You can also take initial momentum minus final momentum, because it is just a magnitude we are going to calculate. That is equal to minus 1 kg meter per second minus 2 kg meter per second. It gives you minus 3 kg meter per second. So minus 3 kg units it is being what? Changed. It depends on which momentum you are taking first, either final or initial. If you take the initial momentum first, it will take as it will come as 3 kg meter per second. So as long as the change in momentum is concerned, we only focus on the magnitude of 3. Alright. So this implies that the change in momentum of the ball is 3 kg meter per second after being struck by the hockey stick. Alright. So this answers your third question. So the main part what I told, this is the convention sign. Had you taken here 5, what it becomes? It becomes plus 1 and all the answer will change. So that is not a good practice. Let us go to the last question of this session. A bullet of mass 10 grams traveling horizontally with a velocity of 150 meter per second strikes a stationary wooden block and comes to rest in 0.03 seconds. It is very less time. It is moving at 150 meter per second and it is coming to rest in the time period of 0.03 seconds. It is very short time to come from 150 meter per second to 0, right? Calculate the distance of penetration of the bullet into the block. Also calculate the magnitude of force exerted by the wooden block on the bullet. Okay, you have a block here. Okay, you have a block. Because bullet is going to penetrate in it, I left the blank here. You have a bullet. Alright, it is going at 150 meter per second. Okay. It is going at 150. So we assume that the velocity here is equal to also velocity here just before hitting it. Okay. Now it is going inside the block and it stops. It is struck inside the block in the time interval of 0.03 second. It stops means what? Its final velocity is 0. So it goes inside and it stops here. Somewhere it stops here. So we are going to calculate this distance. How much penetration it does. For example, it's x. How much penetration, how much distance it traveled inside the block. That is the question. Now, what are the given in the question? Mass 10 grams is given. It is traveling horizontally, as we have already seen, velocity of 150 meter per second, strikes a stationary wooden block. It is not moving, the block is not moving. It is stationary and comes to rest that means the final velocity is 0 because it is being stuck inside the block, it is not moving anymore, that means final velocity is 0. In that time period of, it took 0.03 seconds to stop. He is asking calculate the distance of penetration of the bullet. One of our assumptions is, he asked us the action first to have the force exerted by the block to stop this bullet, because it is coming with some velocity and it is stopping. That means this block is offering the opposing force to stop it, otherwise it can't stop, right? Something should act opposite to the bullet, so it has to stop from such a high velocity. So everything, in order to calculate, we need to calculate the acceleration. Here it is deceleration because the velocity is decreasing here. Is the deceleration uniform here? No, we are assuming the deceleration here is uniform. In the practical world, it is not uniform. When you assume that it is it has a constant deceleration when it is inside the block, we can easily apply the equations of motion. So let us calculate the deceleration first. Alright. What will be the deceleration? You have the time, you have the distance, right? You don't know the distance. So how can you calculate? S is equal to ut plus half at square. So you need S here. You know the initial velocity, you know the final velocity also. Now you need S. So this equation doesn't work for us, right? So the next equation, what is your next equation? V square minus U square is equal to 2AS. Here also you have what? This one, displacement and acceleration together. Acceleration you don't know and displacement also you don't know. So now only the remaining is first equation. A is equal to V minus U by T. Right, this is the first equation. So you know the final velocity is 0 minus initial velocity. What is initial velocity? 150. What is the time? 0.03 seconds. Right. Using this, you will get minus 5000 meter per second square. So the acceleration which we get here is minus 5000 meters per second square. It is a very large quantity, large number. Why it is large number? Because in this small duration of time, 0.03 seconds, it is coming from 150 meter per second to 0. It is halting in 0.03 second. That means the deceleration must be very large. That is why it is minus 5000 meter per second. Now it is very easy, right? You know acceleration is equal to, what you know now, using this you can able to easily find out the distance of penetration, right? You know the final velocity 0, you know the initial velocity, and now you know the acceleration. Using these three, you can able to easily find out the displacement, the penetration that is going inside the block. Let us go and see how we worked out. So this is the everything given mass of the bullet is 10 grams, 0.01 kg. Initial velocity 150 meter per second. The terminal velocity, which we call as the final velocity of the bullet, is 0.0 meter per second, and the time which it took to come from 150 to 0 is 0.03 seconds. To find the distance of penetration, the acceleration of the bullet must be calculated, right? So now let us calculate the acceleration. So using first equation we have to calculate, because we know we have these v, u and t already known. Only we have to know is acceleration. Therefore, A is equal to v minus u by t. So we worked out, so it becomes minus 5000 meter per second square. So acceleration of the bullet after striking the wooden block is minus 5000 meter per second square. Why minus? You already know that, because the force is applied against the motion of the bullet to stop it. That's why it is having a minus sign. Once you know the acceleration, the next thing is, now from the motion equation, v square minus u square is equal to 2as, right? This equation we use. Why? Because we know this part, acceleration. The only unknown is this. So the distance of the penetration s can be calculated as follows. S. So from this you can easily get this equation. If you simplify this, you will get 2.25 meters. So substitute all the values, the result you will get 2.25 meters. I guess you already did this. Now you have this what? Distance of penetration. That means you have a block. From the penetration, it traveled the distance of 2.25 meters. 2.25 meters is a huge thing, right? It takes two men if they are standing parallel. So the bullet which is going fast at the rate of 150 meter per second, you can just imagine that it can penetrate to 2.25 meters. Now the last thing, we have to calculate the force applied on the bullet by the block to stop it. So you know, as the second law of motion, force is what? F equal to ma. So the force exerted by the wooden block on the bullet is, what is the mass of the bullet? 0.01 kg. What is the deceleration it is getting? Minus 5000 meter per second. You multiply the both, you will get minus 50 Newton. So this block is applying minus 50 Newton. That means it is applying 50 Newton on this block, opposite to the motion of the on the bullet, opposite to motion of the bullet, right, to stop it. So it is applying 50 Newton to stop this bullet. So this is what we get. That implies that the wooden block exerts a force of magnitude 15 Newton on the bullet in the direction that is opposite to the trajectory of the block. If the trajectory of the block is in the right direction, wooden block will be stopping to the bullet in exactly, applying the force will be exactly opposite direction, right? Here also we have assumed something. Here we have assumed that the block is not moving. In the question it is given that the block is the stationary block. After you fire the block, generally the block will have a tendency to move. But here our assumption is it is not moving. Alright, so these basic assumptions we are making to deduce this answer. You should all note these small points where you are taking the assumptions. Otherwise, the concept will not be that clear. Alright, so in this chapter, in this session, we have covered these 4 problems, and I hope what all misconceptions you have in this chapter has been reduced in this problem solving sessions. Hope you enjoyed this session, and we will come back with even more interesting problems in the last session of this force and laws of motion. Thank you. Sai Ram.